Finding a point of intersection by addition and elimination. So far we've covered two videos. The first video was how to find a point of intersection with a graphing technique. The second one with the substitution method. And today is the third method, which is finding a point of intersection with the addition method. This is also sometimes called the elimination method. So if you look up additional YouTube videos or resources, make sure you search under both options. Usually this method is students' favorite method, and here is the process. First, convert the equations to standard form. That means get x and y to the left side of the equal sign, and the number or constant to the right side of the equation, or equal sign. Okay, now we're going to focus on eliminating the x variable, and we eliminate variable x by multiplying equation 1 by a number, and equation 2 by a different number, so the coefficients of x are opposites. For example, 6 and -6 are opposites. Please think about finding the least common multiple of the two coefficients that are in front of x. Third step, you're going to add the new equations together. The x terms should add out at this point. Otherwise, you need to go back to step 2 and try it again. Then we'll solve for y. And lastly, you'll substitute the answer for y back into any equation and solve for x. Now there's times where instead of having the x variable be the variable that you try to add out immediately, the y variable might be easier. And so this process can be modified where you eliminate y first. And the example that I'll work through says, find the point of intersection of the two equations, 2x plus 3y equals 7, and 5x equals y plus 6. The very first equation is already in standard form. The x term is first, then there's a y term, an equal sign, and the constant of 7. The second equation is not in standard form. We can see that the y term is on the right-hand side and it needs to be moved over to the left. We'll do that by subtracting the y. So the second equation becomes 5x minus y equals 6. Now the two equations are stacked on top of each other in this method, where the x terms are first, then the y terms, our equal sign, and our constant. We're going to focus on the x terms. Right now they are 2x and 5x. We want to make those coefficients to be opposites, so we'll focus on the least common multiple. The least common multiple between 2 and 5 is 10. So I want to change one of these to be a 10 and one to be a -10. And I'm going to do that by multiplying the top equation by 5 and the bottom equation by -2. Now remember, the entire equation is multiplied by 5. So down below you'll see I have 5 and then a parenthesis around the entire equation. That becomes 10x plus 15y equals 35. And then the second equation is multiplied by -2. So the second equation becomes -10x plus 2y equals -12. At this point, we add the like terms up and down. So we add 10x and -10x. We see they subtract out. We add 15y and 2y to make 17y. And we add 35 and -12 to make 23. This equation is solved in the next step by dividing by 17. We have y equals 23 over 17. Now, commonly when students are learning this method, the textbook or publisher is going to focus on answers that are integer answers. So you'll have nice numbers like 4, -7, or 10. But I know that we also encounter fractions and decimals in our answers, so I wanted to provide an example where I work with fractions for you. Now that I know what y is, I need to find out what x is. So I can use any equation from up above to try to figure out what x is. I chose to use the second equation as I'm solving for x, and this equation says 5x equals. So it'll be easier to solve for x with this equation. What I do is I substitute the 23/17 in for y there. 5x will equal 23/17 plus 6. Okay, so now I need to add the 23/17 and the 6. When adding fractions, I need a common denominator. The 6 is converted to 102 over 17. Then I add the numerators, which gives me 125 over 17. Right now I have 5x equals that 125 over 17. I need to solve for x by dividing by 5. When I divide by 5, I remind myself that I actually need to multiply by the reciprocal of 5, which is 1/5. So 125 will reduce down, and that one will reduce to 25, and the 5 will reduce to a 1. So multiplying straight across, I find out that x equals 25 over 17. So the point of intersection is the ordered pair 25 over 17 and 23 over 17.